French fries are delicious. French fries with ketchup are a little slight of heaven. The problem it is basically impossible to pour the exactly right amount. We are so used to pouring ketchup that we don't realize how weird its behavior is. Imagine a ketchup bottle filled with a straight up solid like steel. No amount of shaking would ever get the steel out. Now imagine that same bottle full of liquid water, like water that will pour like a dream. Ketchup though can't seem to make up its mind. Is it is a solid or the answer is it depends. The world's most common flavor like water, oils, and alcohols. Just wanted force nearly linear. If you put on them twice as fast, they move twice as fast. In those fluid alcoholic Newton ketchup though is a part of Mary blend called non-Newtonate. Measurements to place blue blend a lot of other fluids respond to force non-linear. That is their apparent thickness depending on how hard you push or how long or how fast. And ketchup are actually non-Newtonate. The way number one, harder you push, the thinner ketchup seems to get. Below a certain process, ketchup basically have broken. It switched gear and became 1,000 times thinner than it was before. Sounds familiar, right? Well, number two, if you push with a force below the threshold force, actually the ketchup will start to flow. It is the case time not for is the key releasing ketchup from the galaxy's creation. Alright, so why does ketchup act or work? Well, it's made the tomatoes pulverized, smash, utterly destroy tomatoes. See this tiny particle. This is what remains of tomato cells after they go through the ketchup treatment, and the liquid goes around those that has mostly water and some vinegar through space. When ketchup is just sitting around, the tomatoes particles are usually randomly dispersed. Now let's say you apply a great force very quickly, the particles bump into the other but can't get out, so the ketchup doesn't flow. Now let's say you apply a strong force very quickly. The extra force is enough to squish the tomato particles, so maybe instead of little, they get smushed into little and leaves a boom. Now you have enough space to get past others and the ketchup flows. Now let's say you apply a very weak force but for a very long time. Turn out we are not actually sure that what happened in this second riddle. One possibility is that the tomatoes relatives near the wall slowly get bumped toward the middle. Which similar is basically water. Near the edge, the water serves as a glue gradient between the and the center block of ketchup, so the ketchup flows. And let's say apply ketchup force to is enough to squash the tomatoes, so maybe instead of they get smashed into little ellipse and boom. Now you have enough space for one group to get past other and the ketchup flows. Now let's say they apply a very great force but for a very long time. Turn out we are not actually sure what happens in this second riddle. One possibility is that the tomato particle near the slowly get bumped toward the middle, leaving the soup they was dissolved in, which remember is basically near the edge. That water serves as a lubricant the center block of ketchup, and so the ketchup flows. Another possibility is that particles slowly erase themselves. into a lot of small groups which would then flow past each other. Scientists who study fluid flow and knew actively how ketchup is made first work. Ketchup basically gets thinner the harder you push, but other substances like oil black or some natural actually is thicker the harder you push. Others can climb up, rotate it, or continue to pour themselves out of a beaker once you get them started. From a physics perspective, ketchup is one of the more complicated mixtures out there. And as if that weren't enough, the balance and the process of natural thin vinegar like Xanthan which is also found in many fruit drinks and milkshakes, can mean that two different ketchups can behave completely differently, but most will show two telltale properties. Suddenly starting a tree that holds a more gradual thinning after small force is applied for a long time. And that means you could get ketchup out of the bottle in two ways. Either give it serious long, slow languishing, making sure you don't ever stop applying force. Or you could hit the bottle once very very hard. What the real process you give the bottle a few short sharp shakes to work up all those molecules and then take the lid off. And do a nice control pour onto the heavily French fries.